All right, 8th grade, we have reached the final and 6th part of kind of our introductory chemistry unit here, talking about atoms and atomic structure and atomic theory. Today we're going to focus in on ions. We're going to see that there are a couple of different kinds of ions and talk about how we abbreviate them and things of that sort. So we'll be able to, by the end of this lesson, hopefully explain what an ion is. You'll be able to identify the difference between the two kinds of ions, cations and anions. And you'll also be able to use a set of data or information about an ion to determine how many protons and electrons that particular atom has. All right, so we've got to start out by answering the question, what is an ion? Well, an ion is either an atom or it could be a group of atoms that has either a positive or a negative charge. Now, up to this point, we've been talking almost exclusively about atoms that have a neutral charge. They are neutral atoms, therefore they have the same number of protons and electrons because the positives and the negatives balance out. However, we're now talking about atoms, aka ions, that have either a positive or a negative charge to them. They're no longer neutral. And these ions form when atoms either gain or lose electrons. Now, there seems to be a lot of thievery that goes along with atoms. They tend to steal atoms away from other atoms. Occasionally, they might be considered to be given away, but atoms can either steal away electrons from other atoms, or they might lose their electrons to another atom that's stolen it away. When this happens, they form a charged particle or charged atom, either positive or negative. So how do we write this? Well, an ionic charge is always written with either a plus sign or a negative sign, a positive sign or a negative sign, and then there's a number after it. That number represents the number of electrons that were either gained by the atom or lost by the atom. So we're going to take a look at how that works. Take a look here. This is a close-up photograph of the periodic table in my classroom. Looking primarily here at antimony and tellurium. No particular reason, really. Just happened to grab those two, but you'll notice that happens on this periodic table to be the upper right hand corner. Remember, not all periodic tables are set up exactly the same, but in this one, in the upper right hand corner, there are some positive and negative numbers. And you'll see that if you look around at some of the other squares around as well. But take antimony, for example. There's a -3. Plus 3 or positive 3 and a positive 5. With tellurium, there's a -2, there's a positive 4, and there's a positive 6. That means that antimony, we can find antimony atoms that have a -3 charge. We can find antimony atoms out in nature that have a positive 5 charge, and we can find antimony atoms that have a positive 3 charge. Sorry. So that means that a -3 charged antimony atom means it has 3 more negatives than it does positives. We can see here that the atomic number for antimony is 51, and if it is a negatively charged atom and it has 3 more negatives than positives, that must mean that it has, if the atomic number is 51, that means it has 51 protons, which means it must have 54 electrons because it has to have 3 more negatives than it does positives. All right, we're going to talk about this some more in just a moment. So when an ion is designated with a positive sign, we call that a cation. So an atom or a group of atoms that has a positive charge is known as a cation. And this basically means, if it has a positive charge, that it has lost electrons. Electrons have been taken away from it. It now has more positives, more protons, than it does electrons, negatives. All right. It tends to be metals, that lose these electrons the most and become cations. We'll talk more about this in a few weeks, but metals can be found primarily in the middle of the periodic table. All right, so a couple of examples of atoms that form cations would be sodium and calcium. Sodium, a possible sodium cation would be written as Na, which is the symbol for sodium, and then a little +1, which shows us that that particular sodium atom has a +1 charge to it. It has one more proton than it does electrons. We can also have calcium, Ca, that does exist sometimes as a +2 cation, which means it has 2 more protons than electrons. In the case of calcium, calcium's atomic number happens to be 20. So if it has, calcium always has to have 20 protons. But if it's a positive ion, then that means it only has 18 electrons because it has 2 more protons than electrons. Then we have anions. Anions are atoms or groups of atoms with a negative charge. And this means that that atom has gained electrons. It has extra electrons. It has more electrons than it does protons. Nonmetals are what tend to form anions. Nonmetals can be found at both ends of the periodic table. And the interesting thing is with anions, when we say their name, instead of just saying the element name, we actually add an "ide" on the end of it. So for instance, an oxide ion, or anion, an oxide anion, it could be an O-2, oxygen with a -2 charge. Chlorine with a -1 charge would be known as a chloride anion. Okay. So we use some little abbreviations and symbols when we're talking about these different kinds of ions. We often have the symbol for the element with some numbers surrounding it, and those numbers tend to be in specific spots. So the mass number tends to be in the upper left-hand corner. The atomic number is in the lower left-hand corner, and the charge is in the upper right-hand corner, with the symbol being in the middle. So we see that again here with the lithium. Now we're going to take a look at how we can put that to use. So here we go. We've got, in our top row here, we have the element S, which is sulfur. We can see there a -2 charge. We can see in the bottom left-hand part of the symbol there, we see the number 16, which tells us that the atomic number is 16. So there we have the atomic number. The atomic mass is going to be 32. How do we know that? Well, we figure that out because we know that the mass number is made up of the number of protons and neutrons added together. We can see in our chart that the number of neutrons is 16. Because we know the atomic number is 16, we know that the protons are 16, and 16 plus 16 adds up to the mass number of 32. We can also figure out the number of electrons. We know this is a -2 charged sulfur atom, which means it has 2 more negatives than positives, which means it has 2 more negative electrons than it does positive protons, which means there must be 18 electrons in order for it to have a -2 charge. We also can stick way back over on the left-hand side, we stick a 32 up above the 16 because we put the mass number up above the atomic number in our little symbol of ions. Let's go to the next row. We know we have an atomic number of 7. We can also see if we go down the row that there are 10 electrons. So let's see what we can fill in here. The atomic number 7, if we look at the periodic table, tells us that that is nitrogen, which has a symbol of capital N. We can figure out the mass number because the atomic number is 7. And actually, there should be a 7. Sorry, there's a 7 on your sheet in the number of neutrons. If the atomic number is 7, we know that the protons are 7 because they're always the same. Protons plus neutrons equals the mass number of 14. We know that there are 10 electrons. Oh, we've got our mass number of 14 there. We've got our atomic number of 7 next to the N. We can also figure out the charge. We have 10 electrons. We have 7 protons, which means we have 3 more negatives than we do positives, which means we have a -3 charge. Next row is chlorine. We know that because the atomic number, it says, is 17. And 17, if we look at the periodic table, is chlorine, capital C, lowercase l. We also have been given the mass number of 35, and we've been given the number of electrons as 18. From this information, we can figure out certainly the number of protons is 17 because the atomic number is 17. We can figure out that the number of neutrons is 18. How? Well, we know that the mass number is the protons and the neutrons together. We know that the protons is 17, so in order to get to the mass number of 35, we have to have 18 neutrons. 35 minus 17 is 18. We can also fill in some of the information around the Cl. We know that the mass number is 35. We know that the atomic number is 17, and we can figure out the charge of the atom because we can see the number of electrons, or negatives, as 18, number of protons, or positives, as 17, which means this has a -1 charge. Let's go down to our final row. We have calcium down there, Ca, capital C, lowercase a. We can see there that it's telling us there's a mass number of 40, and they've already filled that in the chart as well, and a charge of +2. They've also told us the atomic number is 20, and from that information we can then glean that there must be 20 protons, because again, atomic number, protons, same thing. We could also figure out the number of neutrons because we know the mass number and we know the number of protons. If we subtract those, we get the neutrons because the mass number is protons plus neutrons. And we can figure out the number of electrons. In this case, if we look way back at the beginning, we have a +2 charge. That means there are 2 more positives, or protons, than there are negative electrons, which means we have 20 protons and we have 2 more protons than electrons. So our electrons are 18. All right, ladies and gentlemen, if you have any questions about this, please feel free to come see me. Otherwise, I will see you tomorrow.